Okay, so we're going to try to graph this parabola here using what we know as of May 1st, which is the zero product property and factoring. So my first step on this is going to be to factor it. I'm going to hurry through this because it's a different, not hurry, anyway. I know that these values are going to be x. 8 is 1 times 8, or 2 times 4. That's the one that's going to give me 2 here, so that will be pen. And it's a positive 2, so that's going to be plus 4 minus 2. Cool. Now, we're going to use the zero product property. Let's put finding intercepts. First, the y-intercept. Is where x equals 0. I have two forms. I'm going to do it in both of them. Let's start with this one. It's going to be y equals 0 squared plus 2 times 0 minus 8. Y equals negative 8. Alternately, I could say y equals 0 plus 4 times 0 minus 2, which is going to be 4 times negative 2, which is negative 8. Oh my goodness, they match. That's delightful. Okay, so we have the y-intercept. It's stuck on our little graph there. Now let's find the x-intercepts. Wrong color. X-intercepts. Well, those are where y equals 0. So I'm going to say x plus 4 times x minus 2 equals 0. We're going to use the zero product property, which says that if x plus 4 times x minus 2 equals 0, then x plus 4 equals 0, or x minus 2 equals 0. Okay, solving. X equals negative 4, 2 plus 2, x equals 2. Okay, those are my x-intercepts. Again, those are where y equals 0. About the only way I'm going to find those at this point in time is to use the factored form of the equation. If I plug these things, well, I can't solve the quadratic any other way at this point. So we've got x equals negative 4. 1, 2, 3, 4. Negative 4. And 2. Put some big intercept dots there. Alrighty, next step. Okay, the next step is to find our line of symmetry. Line of symmetry. And line of symmetry is at the midpoint between the x-intercepts. God, my writing is awful. Okay, so regardless of that, I have one x-intercept at -4. I have another one at 2. To find the average of those, I'm going to add them and divide by 2. That's going to be -2 over 2, which is -1. Awesome. So I have a line of symmetry here at x equals -1. We are nearly there. Okay, so I have some intercepts. I have a line of symmetry. I happen to know that the vertex is going to be on the line of symmetry. And if I read my parabolas right, it's going to be down here someplace, right? My parabola is going to come swooping through here. It's got to come up to this. So let's see what we can do here. That's going to be find vertex. So I know my line of symmetry is x equals -1. I need to find the y value. The y value when x equals -1. So let's do this. Y equals -1 plus 4 times -1 minus 2, which is going to be 3 times -3, which is -9. So my vertex is at -1, -9. So it's going to be -1. It's going to be right there. We are so close to being done. Okay, so the only other thing I need to realize is that symmetry, right? If I come over here, 1, 2, 3, that's that, which means that this intercept has to be 3 away from that. Pretty obvious considering what midpoint is, but that's significant with the parabola because that means that this point here has a reflected point right over here. So we're going to draw that in. And as a matter of fact, no, I'm going to leave it there. So that means I can draw my parabola. Oh, swoop. Look at that. It is a thing of beauty. Oh my goodness. And I have a parabola. And it can be represented as y equals x plus 4 times x minus 2. I can also write it as y equals x squared plus 2x minus 8. And actually, at this point, I could even call it y equals 1 times x plus 1 squared minus 9, because my vertex is at, let's put that in there, -1, -1, -9. So that's pretty cool. We now have 3 forms. We can generally go from this, we can go from vertex form into general form. We can go from general form into factored form. We're going to get a quick way next of going from general form into vertex form without doing the whole parabola thing. Speaking of the whole parabola thing, because this has an a value of 1, and because the vertex is at an actual lattice point, integer coefficients, we can make a more careful graph of this. This goes over 1 and up 1. See that? Over 1, up 1, over 1 and up 1. That means it's going to go over 2 and up 4, 1, 2, 3, 4. And over 2 and up 1, 2, 3, 4. Let's do that. 2, oh good, 1, 2, 3, 4. So you see my sloppy graphing job. That means I'm going to go over 3, 1, 2, 3, and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, look, those 2 points there. So my graph isn't that far, my sketch isn't that far off. I would want to come through there. Oh, okay, that was even worse. But you get the idea. So you know a lot about this creature. And that's pretty cool. Thank you very much for listening. You have a good evening. Ta.